multiplication tape, the pattern, since we have a positive number at the end, the two numbers in the binomials have to be the same sign. And since the number in the middle of this x squared plus 4x plus 3 is a positive 4, both those must be positive. So now I need two numbers that multiply to be 3 and add to be 4. I get x squared plus 4x plus 3 is x plus 3 times x plus 1, because 3 times 1 is 3, and 3 plus 1 is 4. The second line, x squared minus 7x plus 12. Again, the number at the end at plus 12 is positive, which means both my numerical terms must have the same sign. The number in the middle is negative, which means they both must be negative. I need two numbers that multiply to be 12 and add to be negative 7. Negative 4 and negative 3 work, so I get x minus 4 and x minus 3. The third line is x squared plus 3x minus 28. Since the last number is negative, the numbers I'm multiplying in the factors must be opposite signs. And since the middle term is a positive number, the sign of the larger is positive. So I need two numbers that multiply to be 28 and subtract, opposite signs, subtract to be positive 3. What is that? Positive 7 and negative 4. 7 times negative 4 is negative 28. And then a positive 7 plus a negative 4, or 7 minus 4 if you like, is a positive 3. The last line, x squared minus x minus 42, the last number is negative 42. It's a negative number, which tells us what? It tells us that the signs are opposite. The middle term is negative 1, which tells us that the negative number is larger. I need two numbers that multiply to be 42 that subtract, opposite signs, subtract to be 1. 7 times 6 is 42. 7 minus 6 is 1. And again, the 7 must be the negative. The negative must be the larger. So I got x plus 6 times x minus 7. Again, you should have seen this before in Algebra 1. You may have seen it in Algebra 2 if you are reviewing. The key thing is go back and play this tape again to ensure that you see the patterns. There are 4 patterns there. And obviously, if I am looking at a quadratic trinomial, let's go to the board here. A quadratic trinomial of the form, let's say, x squared minus 3x minus 40. I look at that and I say, this is negative, which means my numbers must be opposite signs. So I can go ahead and put the parentheses x plus and x minus. Since they're opposite signs, I'm going to subtract. And when I subtract, I'm going to get a 3. And the larger of the two numbers will be the negative over here. So I need two numbers that multiply to be 40 and subtract to be 3. 8 times 5 is 40. 8 minus 5 is 3. The larger one is negative 8, 5. By the way, a nice way, of course, of checking a factoring problem is to multiply. If you multiply the two factors and you get the original polynomial, you are correct. Okay, now that's the easy part of quadratic trinomials. Let's take a look at the next visual, which has a quadratic trinomial that's a little bit more difficult. Why? Because the coefficient, the number in front of the x squared, is not 1. All the ones we've done so far, the quadratic trinomials, start with x squared. This starts with 3x squared. Now, we know in order to get that 3x squared, we need to multiply an x term times an x term and get 3x squared. The only numbers I know that multiply to be 3 are 3 and 1. So I'm going to have a 3x times an x to get that 3x squared. Now, how do I get that minus 4 at the end? Remember, I can only multiply a number times a number to get a number. Well, the only numbers I know that multiply to be 4 are 4 times 1 and 2 times 2. So really, I have a couple of combinations. Let's try one. The next visual shows you our first try. We try 3x minus 4 times x plus 1. Why? Because we have 3x times x to give us the 3x squared, and a negative 4 times a positive 1, which gives us the negative 4x. I'm sorry, negative 4. The negative 4 times the positive 1 gives us negative 4. So we have the 3x squared, we have the negative 4. Now we multiply to get the x terms. Negative 4 times x is negative 4x. 3x times 1 is 3x. When we add those two up, we get negative x. We need negative 4x. Our try is not correct. Nothing wrong with that. The whole idea is that we try it and we're eliminating. If you have to wind up playing with these kind of quadratic trinomials for a while, you get pretty good at it. But quite frankly, it's not the most important thing in the world unless it's a big number of problems on your test. But I certainly wanted to show you, again, it's just pattern recognition and trial and error where you're using pattern recognition to minimize the error. So now let's look at the next visual. We're going to try 3x plus 2 times x minus 2. Again, the 3x and the x, the 2 times 2. We multiply 2 times x and get 2x, 3x times negative 2 and get negative 6x, 2x and negative 6x gives us negative 4x. We have found the answer to our problem as shown in the next visual. The original polynomial 3x squared minus 4x minus 4 equals 3x plus 2 times x minus 2. That's as tough as it gets with quadratic trinomials. The last thing we want to do is when we have 4 terms, what I called a tetranomial, 4 terms in a polynomial. If we look at the next visual, you could see that we have 3x cubed minus 6x squared plus 2x minus 4. And I've used indicational markings to show that I'm grouping the first 2 monomials, 3x cubed minus 6x squared, and the second 2 monomials, 2x minus 4. This is called factoring by grouping. After we group, we factor a common monomial. Now you'll notice in the first grouping we can factor out a 3x squared. We get 3x squared times x minus 2. In the second grouping, we can factor out a 2, and we get 2 times x minus 2. Notice there's an x minus 2 in each of those terms, which means x minus 2 is a factor of both the first grouping and the second grouping. And therefore, we factor out the x minus 2, and what's left is 3x squared plus 2. So we have x minus 2 times 3x squared plus 2. That is factoring by grouping. How do you recognize that? There are 4 terms. You separate the 2 terms and see when you factor out the common monomial factor if you wind up with a common factor as we did in that particular problem. Let's take a look at the next visual. Again, 4 terms. We've separated them out into 2 groupings. The first 2 terms are grouped together. The second 2 terms. What's different about here is notice the negative 4x as the third term. We'll come back to that shortly. We factor out an x squared in your first group. We get x squared times x minus 1. We factor out a negative 4 in the second group. But notice when I factor out that negative 4, inside I have x, because negative 4 times x is negative 4x, and a minus 1, because negative 4 times minus 1 is a positive 4. When you're factoring, remember you're really reversing multiplication. Be sure of your signs. So now I have an x squared times x minus 1, a negative 4 times x minus 1, or x minus 1 times x squared minus 4. Again, the Siegel rule, if you stop here, you're in trouble with me because you didn't ask yourself the question, can I factor further? Because generally on a test or a textbook set of problems, they will say factor to lowest terms. Well, x squared minus 4 is a binomial. It is the difference between 2 squares. Thus, on this visual, you can see the final answer of x minus 1 times x plus 2 times x minus 2. That shows us all the possible types of factoring. And what I'd like to do now is to go back And the last visual here will show us what the patterns are. You might want to even write these down and have them with you and look at problems in your textbook and identify. The first thing we want to do is find the common monomial factor. Then if the problem has two terms, there are only three possible patterns of factoring. The difference between two squares, the difference of two cubes, and the sum of two cubes. And again, if it's not the difference of two squares, in other words, if you have, for example, x squared minus 50. X squared is a square, but minus 50. 50 is not a square number. It's not the difference of two squares, and it certainly couldn't be the difference or sum of cubes because x squared is not a cubed. In other words, basically look at this and it's either one type or the other, and once you've identified, well, it could be the difference of two squares, then you look to see if indeed the number and the x term, etc., are all squared. If you have three terms, that's a trinomial. We looked at quadratic trinomial factorings. The patterns, recognize the patterns. And finally, if there are four terms, we're talking about grouping. We group the first two monomials, the second two monomials, and we factor out a common monomial and put them back together again. And again, you can always check a factoring by multiplying. Depending on the type of textbook you're using, factoring may be a fairly important thing you need to be able to do in your class. I would suggest that you go back and do as many of these problems until you get absolutely bored totally. Make sure you can master this. Because finally, as promised in Lesson 1, in Lesson 4, we're going to look at solving equations. I bet you just can't wait.